So good morning, everybody. I think we'll just get started in the interest of time. Thank you all for being here today and for making the time to hear about Defence Trailblazer and some of the exciting projects we have to offer. I think we'll start with the acknowledgement to country. So in the spirit of reconciliation, the Defence Trailblazer for Concept of Sovereign Capability acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today, as we respect and value their past, present and ongoing connection to land and cultural beliefs. So for today's session, we will start off with a welcome. So welcome everybody. Thank you for being here. Feel free, it's going to be a fairly informal session, so please feel free to ask questions at the end. We'll have some time, or I'll prompt throughout the session. I will start off with talking about what is Defence Trailblazer and giving people a bit of background. We have Professor Anna Wyatt from the University of Adelaide School of Psychology here with us today to talk about what is research study. And exactly the definitions of some of the terms we use in the academic world, PhDs, MPhils, MRes, etc., etc. Dr. Sanjay Mazumdar, who's our Executive Director for Defence Trailblazer, will speak to us about the benefits of a defence industry-based research degree. And we'll have some industry perspectives from Dennis Medlow from SARB in Adelaide, and also Dr. Chris Escott from DIRAC in Sydney. We've then invited Michelle Norton, who's a current UNSW PhD student, currently working with Tallis, one of our Defence Trailblazer partners, for a research student perspective and how her career has sort of unfolded. And we also have Professor Brian Ng in the room and Alexandra Malloy from UNSW Canberra to talk about their career journeys and give some of their insights as to best practice and how they approach their career. We will have a little break in between, and I will come back to you and speak to you about how to apply and next steps if you're interested, where to find project opportunities, etc. And there will, as I've mentioned, there will be some time for Q&A. So let's sort of relax into it, grab your cup of tea, and I think we'll get going. I'd like to first just briefly encourage you to think about why you're here. So usually at this stage of maybe your career or perhaps your studies, you may be getting to the end of your degree and thinking about what to do next, what's your career path, what are you interested in. Maybe you'll find a research project really inspired you and you've sort of want to consider research at the next level. You may have done a summer research scholarship at some point, or a period of internship with a defence industry partner that may have really inspired you to think, well, what else is out there? So just think about some of those questions. Do you think you have a passion for research but don't really know where it could lead you? Have you been thinking about working in defence industry or doing any further study? Doing a research project with industry and with defence industry in particular, you get to work alongside some of our leading researchers and thought leaders, and maybe that is something you want to be interested in, and somewhere along your journey to date, you've had a bit of a taste around what that could look like. We will also you may have had the question around what's the difference between defence and defence industry. There's quite a significant difference, and some of our speakers will touch on that today as well for you. So maybe I do encourage you to think about why you're here, what sort of questions you want answers to. We are recording the session, and that will be made available to you after the session, and that may prompt more questions. So I encourage you to come back to me directly. But I think at the end of the day, I feel you're probably in the right place if some of those questions on the screen resonate with you. And we will try to provide you with some insights to help you consider if working on a defence industry-led problem is the right step for you. So I will brief you and now just around what is Defence Trailblazer. It's an early initiative that we've only sort of been around for about a year, so we are developing our way forward. It's actually a collaborative partnership between the University of Adelaide and UNSW, and it's supported by the Department of Education through grant funding. So one of the main aims of Defence Trailblazer is to enhance Australia's defence and economic security by transforming the way researchers, universities and industry work together to solve real-world problems, and think about how we're going to increase workforce capability into the future. So some quick notes about Defence Trailblazer on the screen there. So we're one of 6 Trailblazer initiatives that were funded to boost research and development and drive commercialisation around the 6 national priority areas that you can see on the screen. So Defence Trailblazer is one of those, and we collaborate fairly closely with iSpace, the other Defence Trailblazer. So Defence Trailblazer is a $240 million total investment, consisting of funds contributed by industry, Department of Education grant of $50 million, also a co-contribution of from University of Adelaide and UNSW of $50 million. We have a variety of defence industry partners that you can see on the screen. It's currently around 39. There's a couple of them that aren't shown there because they want to remain discreet. And some of our intentions or objectives for Defence Trailblazer is to create over 1,000 direct full-time equivalent jobs in the next 4 years, and potentially an additional 1,400 extra jobs through the broader supply chain. We're aiming to increase our new defence technologies and deliver around 100 new technologies over 4 years to help strengthen Australia's defence capabilities and sovereign capability. So our main aims really, or our 2 areas of focus, are around change. So skilling the workforce of today, and my workforce portfolio has a series of activities to do that, and the industry research program for HDR students is one of those, so that we can shape the workforce of tomorrow. So it's really about increasing capability for current industry professionals, and also to create a pipeline of students with new skills and capabilities coming through, so we can really upskill the workforce into the future. Our other aim is to accelerate research and translation and commercialisation. So we have a second stream that concentrates on research and development activities, and contract research with academics, the universities and industry partners to really develop some of those new technologies that will end up in the defence sector in the future. So before we go on to our first speaker, who is Anna, and Professor Anna Marr-White from the University of Adelaide, I really just want to encourage everybody here today to think big and not small. You may feel like you're going, if you're a current student, there's a big leap for you to make from your current university studies into the big wide world that's out there. So we're just trying to encourage you to think about what is out there, what you would like to do, and really think big today about where your career could take you and what possibilities are there for the future. So if you really are keen to be part of something impactful, keep listening, think about your questions, think about how you can make a difference, and also think about Defence Trailblazer as a potential vehicle for you to really make significant change in the future. So just a quick introduction for Anna. So Anna was trained in experimental psychology and behavioural science and neuroscience and vision science. She was a postdoctoral fellow at the University of Western Australia, held a fellowship at Smith Kettlewell Eye Research Institute, and she's currently a professor in the School of Psychology and the co-director of CNRS IRL Crossing at the University of Adelaide. So over to you, Anna, and welcome.
Pardon me. Thank you very much, Lisa. So yeah, thank you very much for the invitation to present today. This is, I think, a really great initiative, so I'm very happy to be a part of it. So first off, we just wanted to start with a couple of definitions. So I think it can be a little bit confusing that there are lots of different degrees that are available. So I just wanted to quickly go over what the difference is between a PhD, a professional doctorate, MPhil, and a Master by Research. So the Doctor of Philosophy is a doctoral degree with an academic focus. So this is your standard sort of PhD that you would have probably heard about. Under appropriate supervision, you'll develop a significant original piece of research that you have a strong role in shaping and bringing to fruition. And this is usually equivalent to a write-up of about 70,000 to 100,000 words. And that can vary a little bit by discipline. I know that sometimes in mathematics, the theses are a little bit shorter than that, but this is sort of the range. And the idea is that you're contributing that you're demonstrating that you've acquired appropriate skills for research and you've made a substantive contribution to knowledge in the area. The Master of Philosophy, MPhil students train for 2 years. Also, it's just worth mentioning that PhD scholarships are currently 3.5 years. So the Master of Philosophy, MPhil students train for 2 years in research methodology and techniques to engage in the critical evaluation of literature and results in their field of research at an advanced level. So this is a bit different in that it consists of 1/3 of coursework and 2/3 of research. So this can be quite a good option if you're transferring fields. So remember that the Doctor of Philosophy is a degree, and the Master, all of these degrees are ones that are awarded by the university as a whole, so they're not tied to a specific faculty. So you can change areas when you might have done an undergraduate in one field and you want to change to another field. So sometimes people find the Master of Philosophy is a good way to upskill in that particular area before going on to graduate studies. So graduates are well placed to progress to independent research at the doctoral level. And sometimes students start on an MPhil and then transfer across to a PhD partway as well. The professional doctorate, which is offered at the University of New South Wales only for the purposes of Defence Trailblazer, is the perfect choice for professionals wishing to advance their expertise and contribute to professional practice. So this is awarded based on the completion of coursework with a minimum 50,000 word major thesis and a period of professional practice. So this type of option might be quite good if you're in industry at the moment and you just want to upskill in a particular area. You want to take your qualifications that bit further. So the Master by Research, which is offered just at the University of New South Wales for Defence Trailblazer, provides an opportunity to build in-depth knowledge in a chosen field. So the qualification is awarded based on the examination of a major thesis of no more than 75,000 words. So that's 2 years full-time to complete. So that's a shorter, so again, like the PhD, you're doing an independent original piece of research, but it's a shorter thesis and a shorter period of time, so it'll be a smaller project. Okay. Could we go on to the next slide, please? Okay, so stages of the research journey. So what actually happens when you start to do a PhD? So there's quite a few components and milestones that comprise most research journeys. But I think the commonality is that you do start with a research proposal. So this is one of the most important early stages of a PhD. And the first time that you'll do this is actually when you apply. You start with a very rough plan for your research proposal. And the idea is really to establish to show the university and the admissions centre that you have thought about your topic, you've spoken to a supervisor, and the supervisor has appropriate expertise to help you develop your ideas and conduct research in this area. And then once you're actually admitted into the program, you'll do a longer research proposal, which is a really great opportunity to sort of think deeply about your problem and start to sketch out how you're going to approach and tackle that problem. And that can be a little bit overwhelming in the first instance. So you'll be doing a lot in your literature review. You'll be doing a lot of preparation that will end up in your literature review for your thesis then. But it's also really quite an exciting time in that you're learning a lot of new stuff. You're learning to calibrate your ideas with what's going on in the field. And, you're hopefully developing a really good relationship with your supervisor and the research team that you're working in. So it's quite a fun time too. The literature review is a chance to show your knowledge and understanding of the work that's already been done in your field. And typically the literature review will be the first component of your thesis. So this is an opportunity for you to say, here's what's been done so far. Here's what we know. This is the gap that I'm going to address with my research. And this is why I think it's going to take our field further if we solve this particular problem. So that's a really nice, and the things that you do in the literature review, as with most of the PhD, are really translatable skills. So this is where you review a wide body of evidence, you synthesize the results of that and use that to make an argument about why you want to do that particular program of research. Then you actually have to do the research, which is also the fun part. And then once you've done your research, and no doubt, depending on the area that you're working in, you'll develop quite specific research skills in that given area. And then once you've got some results from your research, then you have to write them up. So you write a research paper, which is a skill in itself, and quite an iterative process, but also a very useful skill in the sense that you're being taught to clearly communicate your results to a broader audience. And then you submit a research paper for publication in a journal. And then you finish your research studies. This is what you need to bear in mind as you come to the end of your studies, with advice on submission and corrections. So this is where your supervisor will help you work out if you've got enough or your supervisory team will help you work out if you've got enough to hand it up as a thesis. And then you write it off and send it off for marking and think about what you'll be doing next. Okay, could I have the next slide, please? So in a way, it's kind of life-changing and mind-changing to do a PhD. This is, I think, one of the really useful things about doing a PhD is it's quite an intellectually exciting exercise, really great if you're intellectually curious, and a great opportunity to develop your skill sets. Could I have the next slide, please? So what are the long-term benefits of doing a PhD? I mean, there are quite specific things, and then there are also quite translatable things. So the quite specific things, I think, is definitely developing a skill set and a knowledge base in a given area. By the end of your thesis, you should be the world expert or one of a handful of world experts in that particular problem. And that's pretty cool. You're developing a really great skill set. You're learning how to do all these new things. You're learning how to build your own knowledge base, and also to help other people acquire knowledge as well. Like, you're building the knowledge base in your area, which is really great. You also build on these sets over time, and really a broader perspective on what you're doing in the PhD really is you're learning how to learn in a new area. So you're learning really useful skills about how to acquire technical expertise, how to upskill yourself, how to communicate ideas to different audiences, because obviously you might be doing lots of different types of presentations during your PhD. So you're learning both soft skills and hard skills. So technical expertise in your given area, and also communication of ideas, because these are both really important for a career in science, but also a career in industry more broadly. I think a lot of people who do PhDs do have career satisfaction, in that it's a wonderful way to keep challenging yourself intellectually doing research. There's always new problems to solve, and generally the people you work with are intellectually curious and open-minded, which is really great. It's also an internationally recognised qualification. PhDs from our two institutions were very fortunate in that they're quite highly respected internationally. And you then become a part of a worldwide network or a community of scholars who are working towards trying to increase knowledge in this area. And so that also gives you lots of great opportunities to work and play overseas. Could I have the next slide, please, Lisa? So you can do an industry-related PhD, which is where you work on a topic that is broadly defined in collaboration with an industry partner. And so this is where you might have one member of industry as part of your supervisory team, or you might be embedded within the company for part of your work. It's an opportunity to see your work have immediate impact or address a bigger problem with a team. So you might be part of a team to develop a particular capability. And that can be a really rewarding experience. You'll be working often in a quite multidisciplinary team, and you can see how the company is trying to, or how the industry partner is trying to reach fruition for a particular problem, and how they're bringing lots of different resources together to address that problem. And then your work will be, helping to solve part of that problem. Could I have the next slide, please? So just to give you a more concrete example, in my group at the moment, I'm very fortunate to have two very talented PhD students, Mr. Marlon Blanco and Ms. Lucy Turner. So they're doing PhDs at the University of Adelaide, and they also were fortunate to get a top-up scholarship from the university as well. And so these guys are doing PhDs on topics that are associated with an industry-based grant that my group holds at the moment. And so they're doing our grant. We have two grants with our industry partner that are based on quite a specific problem, but the industry partner realised that there was some fundamental research that needed to be done in order to address their quite specific problem. And so as part of their grant application, we also offered to have a more blue sky theme to the project, where these These PhDs sit along, they're not on the critical path for the industry-based grant, and they're not on that specific topic, but they sit alongside that. So these guys, even though they're not working on that specific industry-based problem, they're benefiting from working in a larger team of postdocs and investigators, and also interacting with subject matter experts within defence and within defence industry. Okay, could I have the next slide, please? Another example is that you can do an actually industry-based PhD, which really is based on a specific problem with industry. So this topic is broadly defined with your supervisory team, which again could include an industry partner, and you can benefit from working in a larger team of investigators and subject matter experts. So the universities also offer opportunities to do internships as part of your PhD program. So you could actually go to work specifically with that industry partner for 6 months at a stretch on a topic associate, the topic that is that helps to broaden your skills in your PhD area. And as part of the industry PhD, you'd also have an opportunity to work with that industry partner as well, and also to see your work translate to impact for that industry partner. So again, this is, you would be working in quite a specific area, but you'd be part of that broader network, both within the university and within the industry. So you would be building up your basic research skills, but also seeing how those skills could be helping to, sort of make a significant impact in terms of bringing capability to fruition. Could I have the next slide, please? So how do you actually start? The first thing, of course, is to check the admissions process at the university or the program you wish to apply to, and contact an academic in the area that you're interested in. You might have a specific topic, or you might see something on their website that is around about the kind of thing that you're interested in exploring. And so they might be offering a specific topic that you'd like to contribute to and then help shape to make your own. Or you might ask the academic to help you develop a topic together. You might say, I'm just interested, broadly speaking, in this kind of area. Could you help me frame a particular question? And next slide. And I guess the final thing I wanted to end on is also to remember that it's a career path. It's not a straight line. So as you go through your PhD, it's I think it's quite different compared to undergraduate studies in that it's not as linear. It's not as, you have a lot more freedom to make it your own, which is really exciting, but can also be a little bit intimidating in the beginning, but that's okay. You're learning to do things a new way. It is a hard thing to do, but you'll be really happy with what you've achieved at the end, I think. Okay, so good luck, and please feel free to contact me if you have any questions.
Thank you so much, Anna. That was really useful. I just wanted to add that we will be talking about PhDs a little bit specifically in this presentation, although there are other opportunities that I will go through a little bit later in my sort of eligibility criteria and what it is you need to do to move forward with Defence Trailblazer projects. And I hope you all found that helpful. If you do have a question, please remember to put it in the Q&A. And if it's a specific question for Anna, perhaps pop her name in the question as well, so that we can loop back to her a little bit later. So on to our next speaker is Sanjay Mazumdar, who is our Executive Director for Defence Trailblazer and actually a defence industry specialist. Today, he brings his insights on the benefits of choosing a defence industry-led research project based on his 30 years of experience as a defence industry specialist. So welcome, Sanjay.
Great. Thank you, Lisa, and thank you to everyone for joining today and expressing your interest in the Defence Trailblazer industry research program. I thought I'd start off a little bit by talking a little bit about my career, because many years ago, about 30 plus years ago, I was in the same shoes that you're in today. So I just finished my Triple E degree, Electrical and Electronic Engineering degree at the University of Adelaide. And I'd started work at Defence Science Technology Organisation, or DSTG as it's now known. So this is in the late 1980s, early 1990s. So I started working at DST for a few years, and during that time I sort of realised that in order for me to really progress my career, I needed to do a PhD. And I also had some very specific areas that I was really interested in and really wanted to become an expert in those areas. So I started my PhD at the University of Adelaide as a DST employee, working in the area of the application of artificial neural networks to guidance and control systems. So this is early 1990s, before machine learning became known as machine learning, but that was my PhD topic. And so that was very much informed by the areas that I was working on at DST and the areas that I thought were going to be really topical for defence. After I completed my PhD, I went back to full-time work at DST, but then sort of realised, for me, having been trained as an engineer, that really what was my passion area was developing products. So I joined Motorola. Motorola was setting up a big global software group in Adelaide. And so I joined Motorola in 1996. And that was a great experience, because I actually then started to work on real product development. Now, I wasn't working in the area of my PhD, but what my PhD gave me was the ability to really think critically, to analyze problems, to develop solutions, to be able to articulate those solutions to other people so they could understand what we were trying to do, etc. So it was a great grounding for my career at Motorola. I was there for 8 years, and I ended up being in charge of one of the lines of businesses at Motorola. But I sort of, at that end of my time at Motorola, I had a hankering to get back to defence. And at that point in time, BAE Systems had a number of major programs that it was ramping up. And so I joined BAE Systems. Once again, I wasn't working in the area that I did my PhD in, but I was leveraging the skills that my PhD gave me in order to fulfill my job at BAE. And I ended up becoming the head of engineering nationally for BAE Systems. So we were Australia's biggest defence company. In my engineering team, we had over 2,000 people. And so I was the head of engineering for BAE. So whilst I started off deep technical, I moved into a senior sort of managerial role. But the skills that my PhD afforded me or gave me were really relevant in terms of being in that head of engineering role, because it meant that I not only had that balance between technology, but I also understood the importance of solving problems and getting capability into the hands of people in the Defence Force. Bit of a segue after that, I sort of became CEO of a couple of collaborative research centres, DSIC, as you can see there, and Data to Decision, CRC. And these were collaborations between industry, academia, and national security. D2D was focused on intelligence, law enforcement, and defence. And that those roles were highly beneficial, because I was once again able to draw upon some of those core skills I learned through my PhD, the problem solving, critical analysis, ability to communicate, etc. But I was also involved in working at the bleeding edge of technology. So Data to Decisions, we were focused on building AI-enabled solutions for that law enforcement community. And so being at that bleeding edge was something that I was doing when I was doing my PhD. I mean, back in 1990, no one had heard of neural networks. The seminal paper in neural networks was in 85. So it was a very new area. So I was at the bleeding edge. I was at the bleeding edge at Motorola, and I was at the bleeding edge at those two cooperative research centres. And so once again, that grounding in being able to work at the bleeding edge, being able to work in uncertainty was really relevant to my time at those two cooperative research centres. I then spent 3 years as a partner in the defence sector for KPMG, Defence and Technology. And so that enabled me to consult to other organisations on how they might solve their defence problems and their defence needs. And so that sort of brought together a lot of that prior experience of, understanding defence, what defence was capability needs were, how to use technology to solve those needs. That sort of gave me a good background for consulting. And then since KPMG, obviously I've joined the Defence Trailblazer to lead this organisation, which is really, as Lisa described earlier, is bringing together industry, academia and defence to solve some of those critical priority needs that defence have got, once again using advanced technology. So hopefully through that sort of long and winding road that has been my 30-plus year career, you'll see that there are some common threads there, which are all about leveraging, advanced technologies, all about trying to solve real world problems, all about combining technology with to solve problems and being able to really communicate the impact of applying that technology. And a lot of that goes back to the grounding I had doing my PhD. Next slide, please. So why choose a defence industry-led research project? I think for me, the big ticket item is really you get to work on those real-world problems. That's something that I always hankered for over my career, is really trying to solve real-world problems. It was the reason why I did engineering in the first instance. It's the reason why I did my PhD. It's the reason why I've chosen the jobs that I've chosen over my career. And so I think the beauty of doing an industry-led research project is that you get to apply your skills to real-world problems. Now, there are a whole bunch of other benefits. Obviously, we're providing a really attractive stipend. We're also going to provide other sort of training and education skills. You get to work in interdisciplinary areas when you work in industry. You're working not only with people in your technology area, so in my area in engineering, electronic engineering or software engineering, but also you get to work with people like Anna, who from a psychology background, or people who are social scientists, etc. So working on an industry problem is very much multidisciplinary. And I think the other bit for me is being able to work with great people, both within industry, and you'll hear from Chris and Dennis shortly, as well as those outstanding academics like Anna and Alexandra and others who are going to speak to you shortly. So you sort of get the best of both worlds doing an industry-led research project. Next slide, please. So I guess the question you might all be having is academia or industry right for you? To be honest, I can't answer that question for you. It's really up to you as an individual. For me, industry was where I wanted to be. And that was because I wanted to work on solving real-world problems, producing products, getting those products into service, into operations, etc. So for me, it was all about being in industry. It was about what was my passion. It was about where did I think I had my strengths. So I think those points about knowing your strengths, factoring in your personality, factoring in what floats your boat, what's your passion, those are all really critically important. For others, my father was a lifelong academic. For him, it was about being in academia. I couldn't see him working in industry, but he was a professor of maths for many years in academia. So for him, the right fit was academia. So it really comes down to you as an individual and really what is your passion. And I think stay true to your passion is the piece of advice I'd give. Next slide, please. Life after research. Well, hopefully you've seen through my career that life after research can take you in many different directions. You can go into defence industries like BAE Systems, as I did. You can go into consulting like KPMG, as I did. You can go into the not-for-profit sector. The sorts of skills you're going to build during your PhD are going to set you up to work in a lot of different sectors. I think that the key skills for me are that sort of critical problem solving, the analysis, the communication, the ability to work across disciplines. Every sector requires those, whether it be the not-for-profit, whether it be government, whether it be, ASX listed companies or consulting, the, Big Four or the next tier. Every sector requires it, but once again, stay true to your passion. Stay true to what really gets you out of bed in the morning. Next slide, please. Here's some stats just to sort of highlight the employability sort of metrics out there around defence industry. I think the one point I'll just make is there are lots of opportunities in defence industries, in defence industry over the next 30, 40 years. Everyone has heard about the nuclear-powered submarine. That's a multi-generation project, but there are other big projects in the defence pipeline as well. So it is a really great time to be thinking about defence industry as a career pathway. Lots of opportunities, really interesting tech, really interesting problems to be solved, and a real commitment from government, industry, and academia towards defence. Next slide, please.
Thank you so much for that insight. I think you look far too young to have had that sort of a career, really. But I think that was really inspiring, and I hope that inspired some of our listeners here today. Thank you so much. Let me introduce our next speaker, which is Dr. Dennis Medlow from Saab, who has over 38 years of experience in ICT, in industry, and in his role with Saab, he specialises in innovation and R&D, particularly in collaborations with industry, academia, and the government. And he's here today to provide us with his industry insights and perspectives on why engaging research students is critical to Saab and their future. Welcome, Dennis.
Good morning, everyone. Thank you for the invitation. I trust everyone can hear me. I've only got 2 slides, so it's not a long presentation. But I just wanted to give an introduction, a bit of insight about, from an industry perspective, why do we do this? Industry obviously is about delivery of projects to our customers. And in Saab's case, our biggest and main customer is the Department of Defence. So we're very focused on the delivery of those projects to our customer. That's how we get funded. That's how we reward our stakeholders. And in many cases, those projects are very well defined. We know what we want to do. We know how we're going to do it, and we deliver it. But we don't always have the time and the resources to consider other areas, perhaps looking at, what's the project after next, or what's going to happen after that, or what's the impact of this new technology, or how do we counter some of the threats that we foresee, or the government foresees coming up that will shape and determine those things in the future. So this is where research collaboration with industry comes in, and it gives us the opportunity to explore issues in the context of the defence problem space that we don't necessarily have the time and intellectual capability to do whilst we're delivering all of these projects. So this is where this sort of work comes in, and we've already run a couple of topics as noted on this slide around computer vision, and we're running a PhD with a student from Adelaide University now on networking in a maritime task force environment. And those topics are giving us quite interesting ideas that we wouldn't have been able to come up with just by ourselves. Not because we don't have smart people, we do, but they are focused on the delivery of those projects. And it gives us the advantage of having the insight, seeing those generated insights, but it also gives the advantage to the students that are working with us to be able to see, firstly, what the defence industry is all about, secondly, work with our people and gain and transfer new skills, and also the opportunity, of course, for them to work on these new ideas and work towards generating novel and original research in their chosen field. I'll move on to the next slide, please. So we're supporting, we're supporting the Defence Trailblazer, and we're looking at a couple of PhD programs. The examples I've got here are examples of the sorts of things that are key to defence in the next couple of years, in fact, over the next decade or two. Autonomy is one thing that is particularly interesting. So we have a project that's literally just been signed for autonomous swarming, and the research will be looking at swarming of UAV objects in a particular context. We're also looking at how we examine and determine the state of things underwater using target motion analysis and multi-static algorithms. So they're just some examples of how of the sorts of things that we're looking at. And this is an example of what Anna spoke about earlier, where we have a concept, we have an idea of where the problem area might be, and we're looking to work with Defence Trailblazer, the university and the student to refine that topic, and then to work with them over the course of a couple of years to produce some worthwhile and actionable research out of that. And as I said, with the projects we've already seen, particularly with the one that we've only, that's about a year in, we've already seen significant benefits from that student who's working with us currently in his internship for 6 months, and he's gaining a lot of skills, and we've gained already some significant value from that. But that's really all I wanted to say. So there is benefit that we see from industry. We are very open to engaging with the Trailblazer, the university and the students. And we certainly would like to get applications for the projects we're putting up. So thank you.
Thanks so much, Dennis. And thank you so much for your support of Defence Trailblazer and being so engaged. We're looking forward to working with you more in the future. Dennis will actually be with the presentation for the duration. So if you have any questions around the projects that he mentioned, please hang around and feel free to ask those at the end. I'll just move on to our next speaker, Dr. Chris Escott from Dirac. Chris actually wears 2 hats. He's the head of engineering at Dirac and also quantum device design engineer with UNSW. So in his position, he sort of sits on the edge of academia and translatable research that I think Sanjay sort of alluded to in his talk. And so what he does can be applied directly into defence industry. So I'll leave Chris to talk us through Dirac's vision for the future and how his career has progressed through study and application of his knowledge into the defence space. Thanks, Chris, and welcome.
Thanks very much for the introduction, Lisa. So yeah, it's very indulgent to be able to come here and just talk a little bit about my journey to where I ended up today. You might actually hear quite a few similar stories as to what Sanjay talked about earlier. I promise we didn't corroborate on these presentations. And if you get bored of repeated messaging, then just feel free to tune out and enjoy the colorful pictures on my slides. So as Lisa mentioned, I am the head of engineering at Dirac. And quick introduction to Dirac. We're quite a young company. We were only incorporated in May last year, but we're commercializing technology that's been developed at UNSW for more than 15 years. So this is a CMOS quantum dot quantum computing technology that was developed within Professor Andrew Dirac's research group at UNSW. And he's our CEO. So our vision here is really to develop fault-tolerant quantum computers. So these are very large, complex, engineered solutions for quantum information processing. And so we have very big aims, very big goals, and we've got a great team to deliver this. We have a great diverse group of engineers and physicists. And we work very closely with UNSW. As Lisa mentioned, we're actually on campus in Kensington at UNSW. And so we work with, on last count, 18 PhD, masters and honours students at UNSW. So we have a reasonably large interaction between the company and the university. We also recently received $6 million in funding from state and federal governments. So we are in a growth phase. So things are moving quite quickly at the moment. So if you can go on to the next slide, please. So my current role as head of engineering has a bunch of responsibilities. I need to deliver on engineering solutions to be able to scale up the size of our quantum processors. So to do that, I liaise with external stakeholders, external semiconductor foundries that are going to be fabricating our scaled processors. So there's quite a bit of technology transfer involved in that in order to be able to take our designs from our prototypes that we fabricate on site at UNSW here, be able to fabricate them in the high yielding semiconductor foundries. So I also manage the IP for the company. I do quite a bit of project management and people management, but generally as a startup wearing multiple hats, which is quite a common scenario. So on to the next slide, please. So how did I get here? And again, quite a similar picture that you might see more than once today. I guess I have a slightly unconventional route to how I ended up where I am. I first started in a research program at UNSW called Taste of Research, which gave me a scholarship to work on a project over summer in quantum computing. And I immediately loved it. And the allure for me, as Anna was mentioning earlier, is the real draw to be able to create something new, and also to be able to focus on one thing to the point where you become a world expert in that one topic. So I knew that was for me. I wanted to go through and do a PhD, so I completed that at UNSW. I did a brief postdoc as well. But then I landed a position in industry at a semiconductor foundry in Sydney. And interestingly, even though it was still in technology development, it was in a completely different field. So it was working in optoelectronics, something that I had not done before, but I was able to bring the skills that I'd learnt from my PhD and the knowledge to be directly valuable to a company. So if you learn nothing else from my rambling today, it's that there are examples where you can develop skills that are relevant across many different industries and many different sectors from completing a PhD. So after a while, as my role in industry transitioned more into product development, I realized I wanted to personally get back into technology. So there was an opportunity for me to rejoin quantum computing research at UNSW. So I did that, and it had changed quite a bit since I had completed my PhD, to the point where we needed to really move much faster than we had in any time in the past. So we took on some seed funding, commercialized, incorporated the rack, and now we're off and running. So the point here, it's very similar to what Sanjay was saying, that at every turn in their career, I was really acquiring new skills, and I could apply them and become more valuable at every new opportunity that I took on. So on to the next slide, please, Lisa. Yeah, so I just wanted to take a quick minute to talk about what I see as the benefits for an industry PhD program, like as in the Defense Trailblazer Initiative. A question I often get is, if I do a PhD, what are the job opportunities at the end of the PhD? Because they're 3 years away, 4 years away. It's very difficult to predict. But I can tell you that in an industry-linked program, you're developing skills that are directly useful for that industry partner. So as a hiring manager, if I'm training you for 3 years, I'm going to want to employ you at the end of it for sure. So that is a massive advantage of these kinds of programs. And obviously, you also get to multiply some of the international connections and partners, collaboration opportunities and travel opportunities from both your academic supervisors and your industry partners. So that's what I also see as a big benefit. Some of the skills that I look for in employees are obviously relevant technical skills. As Sanjay was saying, problem-solving skills, and maybe something that is a little bit more nuanced, but is an underrated skill, in my opinion, and that's the ability to cope with uncertainty. So developing initiative and problem-solving skills, things that acquire during a PhD program that I personally find very valuable in employees. So to the next slide, please. So the RAC has one project live at the moment within, or soon to be live, I should say, in the Trailblazer project. And this is based around modeling and simulation of our quantum dot devices. So we have an ongoing need to understand complex interactions of electrons in our quantum dots. And this program that we've developed is designed to apply existing and also develop new ways of simulating, modeling these complex interactions. So a very interesting project. And so in the interest of time, I'll go on to the next couple of slides. I just want to flash up that, again, relating back to the career opportunities at the end of PhD programs, in the quantum space in particular, there is quite a bit of data being generated at the moment. That there is really a rapid expansion underway. And SIRA released an updated report earlier in the year that actually put some numbers against this. And they said that up to 2030, this quantum industry is looking to generate 8,700 jobs, which is a massive amount of jobs. So this is really exciting. So I just want to flag that. And then on the last slide, I just want to say thanks for inviting me again to talk to this forum. Thanks for listening. If anyone's interested in studying or working with us, my email is there. Feel free to drop me a line. So, thanks very much.
Thanks so much, Chris, and also for sort of just reiterating the fact that there are some really great job opportunities in the future for students who sort of engage here. So something that I encourage you all to keep in mind. Thanks for your time, Chris. Will you be here to the end of the session for questions?
Yep, I can hang around.
Okay, excellent. Thank you. If I can just introduce my next speaker, Associate Professor Brian Ng. He's actually from the University of Adelaide. He's currently primary supervisor for a few Defence Trailblazer projects, one with Silentium and the other one, and he also involved with one with SRC Oz. And just a quick introduction for you, Brian. Please go ahead and welcome. Thank you for supporting us.
Thanks, Lisa. Can you all hear?
Yes.
All right, thanks. Yeah, it's a great pleasure to have this opportunity to share with you an academic perspective on Defence Trailblazer collaborations and projects available. So first, a little bit about myself and the Research Centre at the University of Adelaide in the School of Electrical and Mechanical Engineering. So I was a Adelaide product from undergraduate and PhD onwards, and currently I'm the director of Adelaide Radar Research Centre. The centre itself is about 15, 20 years established ago by a now retired colleague of ours, and he set up quite a few collaborations with defence and related industries, and I'm very grateful for the foundations that he and the other academics have laid for the Radar Research Centre. Now, my background is in signal processing. That's what my PhD was on. And about 10 years ago, I started working more of radar signal processing problems, including sensor information processing and using radar as a remote sensor for primarily defense projects, but also on civilian applications, such as remote sensing, soil moisture, and the likes. We're excited with the Defence Trailblazer because radar technology is really critical to defence, the aerospace industry, and various resource management. There are many different applications that I would say also dual purpose. So these it's an excellent training ground for students who are interested to enter the defense industry, but also interested in the broader use of technology as well. And the Radar Research Centre is fortunate enough to have industry links, and we have ran a number of industry-related projects, and some of the outcomes are sort of scattered along the slide there. So we had some drone classification work, as well as some maritime radar problem solving with signal processing approaches, and also there you see a little a boat, and that's a maritime inverse synthetic aperture radar imaging project that we ran collaboratively with our international partners. So can we move to the next slide, please? So I'd like to share with you 2 more slides with ongoing collaborations and defense trailblazer opportunities. The first slide here relates to our ongoing collaboration of SRC Australia. They are the Australian, I wouldn't say they're not the child company, but the Australian branch of the SRC Corporation based in Syracuse in the US. They've long had a presence in Australia and also in Adelaide. So, and over the years, we've had already several honours level collaborations, and we're very pleased that SRC is able to offer several more opportunities under the Defence Trailblazer program. Now, I'm presenting these 2 opportunities on behalf of 2 of my colleagues. The first one is supervised by Dr. Nia Nguyen Trong. He is an antennas expert in the School of Electrical and Mechanical Engineering. And this project is about designing RF emitters with a direction finding capability. Now, within an electronic warfare context, which is where the interest of SRC Australia is, it is critically important to first detect and then characterize the various RF emitters that are present in a contested environment. And one of the key tasks to identify RF emitters is to actually find which direction they're coming from. So direction finding or direction of arrival estimation, to give it a more wonky term, is a critical part of what we do. Now, Nia's project is really looking to look at a novel combination of hardware sensors and accompanying algorithms to achieve direction finding in an efficient and preferably a lightweight platform. Now, if you're interested in this PhD opportunity, there is a QR code on the left side of the screen at the bottom left that will take you to a lot more information on this particular project. And Nia, he's easily findable on the university directory as well. I should have included his email in this presentation, but more than happy to put anyone through to Nia if you have an interest in this project. The second SRC Australia PhD opportunity is more on the processing side, which is after the signal acquisition with the RF receivers. Now, this project addresses the really dynamic and complex RF environment in which electronic warfare participants find themselves in. So there are classically 3 separate areas of electronic warfare that's illustrated on the screen there. There's electronic support, electronic attack, as well as electronic protection, offering various amounts of various aspects of the battlefield. So an essential part of supporting these functions is to identify the difficult challenge of predicting the behavior of the various RF emitters, which are typically radars in a particular environment. And this is really valuable for decision makers in the EW area. And with the recent advances in machine learning, then in cognitive electronic warfare, we are looking to explore using machine learning ideas to perform the identification and the prediction of RF emitter behavior. Now, this project is led by Dr. Faris Daoub. He is a colleague at the University of Adelaide in the School of Computer Science, and he is also working at the Australian Institute of Machine Learning. He is an AI expert or machine learning expert, and he's happy to lead this work in identifying suitable machine learning approaches for solving this problem in the EW domain. Like the other project, if you're interested in more information, the QR code on the bottom right corner will take you to the site, the web page for this particular project. Again, if you're very interested in this and can't find Ferris's email address, please contact me. I'm very happy to put you through to Ferris. Oh, and I noticed that the just been pasted up in the chat area. Thank you for that. The 2 supervisor profiles, so you can click on those links straight away and learn more about these 2 supervisors. Can I have the next slide, please? Yes, thank you. And the second collaboration is with Silentium Defence. Now, they're a South Australian company founded by DST veterans. And if I'm not wrong, they're about 7 or 8 years old in this area. Now, their specialty is in passive radar systems and the capabilities that you can achieve with these types of systems. The origins of this project comes from the fact that near-Earth orbits are really congested these days, with a multitude of operators with much assets up in that particular region of space. There are many there's a pressing need to have a greater awareness of the various assets and what they're doing, and this general thrust can be addressed by a number of different technologies. Where Silentium comes in is that their passive radar technology has some very definite operational advantages and strategic advantages, in that they're transmitter free, so you don't need a very, very powerful terrestrial transmitter. And this also means it's very good for stealth observations of what's happening in the space area. And Silentium has a track record of already delivering systems of similar capabilities. Their current setup of passive systems of passive radar can already detect space objects using terrestrial broadcast signals. And this is already, in a sense, is already proven technology. However, there are still many technical challenges that require further investigation, and in particular, signal processing approaches required to detect and classify objects. And this is where a collaboration between the university and Silentium is valuable, because we have people in this university who are interested in signal processing, including myself. We would like to have access to the tremendous amount of real data that Silentium's existing passive radar structure is recording. And this is going to be a minefield, in particular, sorry, not a minefield, a gold mine, wrong metaphor there, for the PhD project, because many academic research work in the open literature cites or evaluates the performance on simulated data or some kind of synthetic data. Silentium's many collection of real data set is going to be really useful for making important breakthroughs in this domain. And a big selling point, as others already pointed out in this session, is that the PhD project, throughout the PhD project, the student would have very close interaction with the industry experts, because they're based in Adelaide. They're about 15 minutes drive from the campus, so it's really easy to shuffle back and forth and get some very in-depth collaboration. And I already have an existing success story here. If you look at the picture on the bottom here, the gentleman closest as green was a PhD student at University of Adelaide, and he subsequently did a short internship at Silentium several years ago, and now he's a member of staff there. So it again touches on some of the themes that others have already spoke of. For instance, Chris just spoke a little bit earlier about the nexus between industry and academic research, and how that can lead to both a rewarding education experience, but also more importantly, a clear pathway to an exciting career in a really growing discipline. So the last thing is the primary supervisor is myself in this project, and the QR code is also on screen. If you're interested in knowing more about this project, please get in touch to myself, or perhaps if it's through Lisa and others can get through to me.
Thanks.
So that's all I have for today to share with you, and love to be able to answer questions you have if people have any touching on any of these projects described today.
Thanks so much, Brian, and happy. Thanks so much for your overview of the projects. They sound really interesting. I'm not sure who's going to tell Sanjay that I'm going to come and work for Silentium or SRC Oz to do a project. We'll see. Brian, are you? I'm not sure if you're having to go or you're here until the end.
I'm sorry, I've got to teach in 20 minutes, but I'll hang around for the next 20 minutes. And
yeah, no problem. Thanks again. We are going to move to a bit of a break. Please continue to post your questions on the Q&A. We'll take sort of 5 minutes, well, till about 11:15-ish. Grab a cup of tea, have a toilet break, and see you back in about 5. Thank you, everybody. Welcome back, everybody. I hope we're back in the room. Everyone's managed to stretch their legs for the second half. And to kick off the second half, I'd like to introduce Michelle Norton. Michelle's actually a very busy person. She's currently undertaking a part-time PhD and works full-time as an engineer for Thales Australia. Her PhD topic, I believe, is aligned with her old day job at Thales, so she's since changed roles, but continues the same PhD topic. So I'll get her to speak further about her journey and what she's experienced and, you know, some of the great things she's done. And I'm looking to hearing all about your journey, your research journey, Michelle. So thank you for being here today and welcome.
Thank you. Just check, can everyone hear me?
Yes.
Yeah. Okay. So I want to keep this relatively quick, and if anyone has any questions, I'm sure Lisa's able to pass them across to me, and I'm happy to chat with anyone outside this meeting. So my entire tertiary education has been around the defence applications of engineering, just as some context. So I did my undergraduate at UNSW Canberra, and then went to work for Thales Australia in the dock operations and reticulated services team. And then in the time that's passed since then, I've completed a master's in guided weapons systems, which is related to my new role, but I've also started the PhD that I'm currently working on as well. So if we jump to the next slide. The reason I wanted to look at research as a degree of sorts was in the day job I had, we were looking at replacing a bunch of large infrastructure, particularly valves that are used to control the water flow in and out of the large dock in Sydney that's on the screen. And what struck me a lot was a lot of the applications for maintenance, the methodology and the planning for downtime hadn't caught up with what was available with the new technologies that had developed since the dock was built. So we're talking about run to failure with no maintenance planning or similar, or just fatigue monitoring systems. And I wanted to look at how we could better use a range of different disciplines together to better predict when failures would occur to minimize downtime on the system overall. So that's where the ideas come from. The topics expanded a little bit, but the main disciplines I'm looking at is the modeling and fluid structure interaction, as well as how we can use that to monitor the fatigue and the cycles to failure on these large valves that have lives of 20 to 30 years. So this is a long-term monitoring type regime that we're hoping to be able to pull out of this at the end. So that's sort of what my research topic is. Now, if we jump to the next slide, I think the key question everyone tends to ask me is, how do you get some kind of work-study-life balance? It's a challenge. It's more like a swinging pendulum. Some weeks you'll get far more time to do your work and your research, you need more family time. And then other times you might need more study time, and just finding that balance and making sure that's maintained. It has been more challenging with the role change away from maritime, when I'm trying to focus on one side with a maritime program, and the other side of the time I'm dealing with rocket motor development problems, and they're two very different applications and mindsets to jump between. The other challenges that I've dealt with recently is my husband's in the army, and we got posted to the UK for 12 months. And in amongst all of that, my employer asked if I would consider doing the Masters of Guided Weapons Systems over in the UK at Cranfield University, which resulted in suspending all my study for the PhD and trying to balance nearly full-time study and nearly full-time workload, which is not advisable. I highly recommend part-time for either study or work if you're thinking about doing work and a study degree. It's a lot easier to keep that balance and not lose all your other activities that you need to stay sane. And then, so with come back from the UK and started to return to PhD study, but then with other life planning things, I'm about to head off on maternity leave again. So be back doing the PhD hopefully from the start of next year. I think I have one more slide. Doing the study that's related to work or has the direct application for work is really good. You can pull skills from work across to the PhD, as well as bring a range of different skills you've got from the study side of things into the work environment. And that might be a little more applicable to my current role, where it's research and development type programs rather than just ad hoc engineering tasks in my previous role. But there's a lot of I say tools, but skills that you can develop from both that cross over and can help in both applications. And obviously with the extra background knowledge, and in the future there'll be extra work opportunities that'll come up based on those skills that you've learned doing your study. So I think that's all I've got, unless there's anything that anyone has immediate questions.
So just a quick immediate question from me, Michelle, and that was really interesting. And I thought what was interesting for me was your opportunity to be able to pivot and sort of explore new opportunities. Have you found that every time you've changed something or changed your pathway, the opportunity has just sort of presented itself, or you've had to go looking for it?
In quite a lot of cases, the opportunities end up linked. So if I wasn't already doing the study and the PhD work on top of my general workload, the opportunity to do the master's wouldn't have come around, if that makes sense. So there are opportunities that build on each other, and some of them you look around for, but I find a lot more often than not, it tends to build on themselves.
Yeah, I think that's really interesting to know, and also the fact that you're being able to balance lots of different elements of your life, even though you're so busy and got your fingers in so many pies. And I feel like doing a defence related PhD or master's study is a really good way to find that balance. Certainly a benefit. And I think the point that you made around considering part-time study or maybe a master's by philosophy degree as opposed to a PhD is something that I'm happy to talk about to anyone who's interested, maybe a current industry professional that would like to go down that path. I would certainly work with people to work out a model that is going to work for you, for your company, and for the university and the supervisors supporting you. Thank you, Michelle. Is there anything else you'd like to add?
No, I'm happy to take anyone's questions or organise communicating by email with anyone who's got questions. So.
Yeah, great. Excellent. Thanks very much, and happy to pass those through to you. We're going to keep rolling. There is for those of you who have joined halfway through or partway through, please keep posting your questions on the channel. We will have a time for questions at the end, but as it stands, I'll introduce our next speaker. Thank you so much again, Michelle, for coming to help us with the information session, and we'll be in touch. Feel free to stay until the end, or as long as you need to as well. Let me introduce our next speaker before I come back and start to talk about how you express interest or find project opportunities. I'd like to introduce Dr. Alexandra Malloy. She's an academic at UNSW Canberra, located in ADFA. She's a behavioural scientist, so she explores various aspects that influence safety, aspects of human factors, human performance, and human-machine interaction. Her specific area of expertise is in developing training interventions to improve operators' behaviour and non-technical skills around risk management and situation awareness. She's currently engaged with CAE and is offering a Defence Trailblazer Supporter research project with CAE, and is here to speak to her career journey as well and tell us a bit about the CAE project. So thanks, Alexandra, for joining us, and looking forward to hearing your story.
Thank you so much, Lisa, for your introduction, and good morning, everyone. It's a great pleasure to be here today, and for the opportunity to talk from the academic perspective. So we heard a little bit from industry perspective. We heard a bit of a PhD candidate as well, insights, but I will continue sharing some insights from the academic perspective, and I'm happy to answer any questions that you may have at the end. So to begin, I would like to share some insights from my career path and how did I get to where I am at the moment. And I can tell you one thing, so straight away, that learning is that lifelong process. So, and interestingly, when I completed my first degree in education, so I was so excited to start working and get into the academia and really apply the skill that I had. And I thought that I will never get back to university. I will never do any other programs. So that was the end. However, it progressed to another master program and followed by another, PhD program. And it really followed my passion and my drive into the area that I wanted to be. So just several points how you can get into a PhD stream. First, if you just want to continue doing your progression after your bachelor or master. The other path is you have decided to work in industry, but then after a while you would like to combine some experience, but also develop more professional skills. And you can get back to the PhD stream really when you have already worked for quite a while and you really would like a little bit of a pivot or a little bit of a change and really combine those skills. So that's what I found happened to me as well. After a while, I came back to academia, and the most frequent question that you will hear is where you would like to be. Is it industry? Is it defense? Is it academia? And it's really come back to those skills and to those points that our speakers were saying previously. What is your passion? What's your personality like? What do you prefer? What are your career aspirations? So what do you really see yourself in? And my particular journey was in the non-technical skills, so in more human factors related area. And human factors is really combined those areas of psychology, engineering and design that I was really passionate about. So in such a way, I completed my PhD and I proceeded to academia. I knew that that's the path that I'd like to proceed. So currently, I'm senior lecturer in aviation and leading the program in aviation at UNSW at the Australian Defence Force Academy. Following that passion, I think that was important to engage with industry and defence and to collaborate to know what are the new technologies. And when we know that the new technologies are coming in place, it's really coming to the point, but where does humans sit with that process, with that technology? How does the technology affect the human behavior and human performance overall? And continuous knowledge about it really just came to those areas that I'm interested, like human factors and safety, and really in different applications. So I've been also working in the industry as a human factors specialist, working on major transport projects, including, airports and railway and road safety. So the areas of application can be different, but that ability to apply your skills and knowledge and to pursue your passion really remain the key. So you also have some rewarding parts when you receive a fellowship or award based on your work that you do in collaboration internationally or in Australia. via attending conferences or networking events. Next slide. So you'll see on this slide, you just need to keep pressing the button so it will appear. Feel free to keep doing that. So as you've seen, so I have a number of experience of working with simulation as such. So this was when I was part of the University of Nottingham in UK, and I had to experience the different types of simulations, starting from the high fidelity 360 simulator for the driving part, to the rail simulator and healthcare simulation, bicycle simulation, and up to Australian research study when I was here in Australia. So I was doing the on-road study with young trainees using low fidelity and high fidelity simulation. So I think that passion to continue different research, including that simulated study, remained. And I had a strong interest about it. And obviously, like when you think about mutual areas of interest, so when I looked at the industry, so I really saw on the horizon that the company CAE was doing a number of simulation studies and just different industry projects with the simulation in defense. Next slide. And I think the idea for the study that we are currently planning to execute came together. So new technology, which is a simulation, and biometric equipment such as eye movements and eye tracking, combined in that question that we're currently trying to explore in one of our defense trailblazer projects, in developing a unique system for assessing cognitive load and situation awareness for mission aviators, including drone operators and sensor operators. We're trying to develop the system, but also implement RAS AI for mission operators' task, and a combination of different objective data such as flight simulation and biometric is really great technology that can provide us that result in terms of improved training, improved performance, and all other applications that can come out of that. On that note, next slide, please. So I am also currently leading one of the PhD opportunity, and I'm still looking for the candidate to apply. So the project really itself will focus on the new technology and understanding whether artificial intelligence can improve training of unmanned aerial systems operators. And again, we come back to the point that innovative technology, including artificial intelligence and simulation-based training and biometric technology, such as eye tracking, really show those results and great positive results in improving aviators' behavior and performance. But as we move into more effective training of the US operators, we'll always come to the point, what is that effective training methods? What are effective ways of delivering safety messages? And I think that remains at the core. So how do we provide training? How can it be done more effective, more in an accelerated way? And how do we maintain those soft skills of the operators to ensure the best performance? So you can see that our collaborative project with CAE is available. Again, if you scan that code, you'll be able to access some more information, and followed by further Lisa's information about how to apply. And what I'd like to end up for today is really to give you a little bit of tips and just insights. I think if you think about entering a research degree and these industry-led research projects, I think it's actually great, because if you think about you have an opportunity, you have that platform that combines a number of projects, a number of areas just in one place. So in the past, I used to search internationally and nationally, different areas and industry partners, and it takes a while, and sometimes you can just lose that interest. In Defence Trailblazer, you can have those specific areas of expertise available in one place, and really have great benefits. Another part, I would just say that be courageous and talk to academics, talk to industry people, talk to people from Defence Trailblazer to understand how to enter or to give them answer your questions, because sometimes when I think and talk about PhD opportunities, even to industry specialists, they think it's very hard. So that just straight away goes in mind, like it's very hard. I'm not sure. As Professor Anna was talking before, obviously there are different also paths. You may choose, master by research, or you can still do that PhD, and you have to be open-minded and get your questions really answered about the questions that you may have. So yeah, if you have any other questions, I'm happy to answer them, but thank you very much for this opportunity to talk.
Thank you so much, Alexandra, and thanks for sort of providing detail on the CAE opportunity for students. I hope for prospective students. So I hope people have been very inspired about what you've heard today. Some great projects, some excellent speakers, some interesting journeys. I'm hoping some of you can actually see yourselves taking a similar journey. And if you do have any questions or would like to have a follow-up discussion, please come back to me. I'm happy to connect you up and talk you through next steps. For this next section, we've only got a little bit more time left in about another 20 minutes to go. So please stay with us. I hope you've enjoyed the session so far and heard or listened to all of the speakers that we've had. I'm going to talk you through what we do next, the nuts and bolts of how you actually apply, how you find projects, etc. Opportunities are born and not made. I think we all know that. We do have a list of projects on our Defence Trailblazer website that you may be interested in, but there's also other opportunities to be able to make a project that you're interested in. So I suggest you may have already been speaking to your industry employer about a potential defence-focused project. We do tend to work with our Defence Trailblazer partners that I showed you before, but also happy to consider collaborations with other defence industry partners if they'd like to come on board and come along with us for the journey. So happy to speak to you if you're currently employed, would like to talk about a project, etc., or have an idea that you think would be useful for the future for the defence industry and defence. Speak to your, Alexandra just mentioned, speak to your academics, as did Anna. Speak to your academics, speak to your honours supervisors, people around you, academics who are already collaborating with defence industry partners that may be interested in proposing a project is always a good place to start as well. Projects can always be slightly tweaked to your specific interests, so don't be afraid to have those discussions. It's a good way to get the conversation started. You might be considering doing a research study that's complementary to your work. We heard from Michelle, who talked about some part-time studies that might be a way to actually achieve that work-life balance and still do something really exciting and something that's really going to support your future career path. You may have even undertaken a recent internship with a defence industry partner, and that's also a good place to start to have those discussions to see what else you can do with them to collaborate. So please come back to me. Don't be afraid to sort of start your own discussions around opportunities that may be out there, and happy to help you with that. So the industry research program itself, we've had a lot of discussion around the edges of doing these projects and what they are. I wanted to give you some detail around the HDR opportunities in the program itself. So what we're offering are 50K per annum tax-free scholarships. That contribution is made up by 40K through Defence Trailblazer funds, grant funds, and also by a 10K per annum with industry contribution. of course, it's tuition fee. If anybody does a Commonwealth supported PhD or a master study, high degree by research study, tuition is actually free. So not something that you end up having to put onto HECS and pay off later. So please do keep that in mind. There's always going to be an internship component opportunity with a Defence Trailblazer program of study. We would like that to be around minimum 60 days, but encourage people to do it for 6 months. And that gives you an opportunity to really immerse yourself in the placement with peers, enables you to network, etc. Throughout, and that would be throughout the term of your studies. We have UNSW or University of Adelaide projects available. I encourage you to still follow up. You know, you might decide that you wanted to shift to be able to engage in a project in a different state. And, you know, we'll certainly talk you through how that happens as well. All the programs actually have joint supervision. So there's always going to be a primary academic supervisor and an industry supervisor, and there may potentially be a co-supervisor as well that would support the project. And you become a team to work through that particular project together. Of course, the intention, I started at the beginning of the session talking about what are we trying to do here with Defence Trailblazer, and that is actually about, one of the aims is to increase that workforce capability. So we feel these types of HDR programs are a great way for you to get a taste of what it could be like in the future, and also for the companies that you're working with to create opportunities for you for the future, so that we create that pipeline of students coming through and our future talent that the defence industry and defence actually is very much in need of at the moment. The PhD and the professional doctorate degrees are 4 years of full-time study, including that embedded internship period. We have the Master of Philosophy and the Research Masters program that Anna talked about at the beginning. We're talking about 2 and 2.5 years full-time study. There are actually part-time options to do a master's as well. And that is to ensure that the research you're doing stays topical and current and relevant at the end of the period of your degree, so it can be easily translatable and transferable into the defence industry space. Industry professionals. We certainly do encourage you. You're exactly the right type of people that industry are looking at upskilling and helping you build on your knowledge. It would be an optional internship period, and because you're already located in industry, I would be suggesting that you consider an internship maybe back at the university that you're studying with. There's opportunities to spend significant amounts of times in labs, etc., that actually support your research project. So it's not out of the question just because you're already located in industry that you can't actually explore other environments and build other networks outside of your current workplace. We would look at other, obviously we wouldn't expect, I wouldn't expect people to be dropping their salary necessarily to take a 50k per annum tax-free scholarship, but we would consider ways to be able to incentivize, perhaps through professional development opportunities, travel opportunities, salary, incentivizing through your salary is another potential model that I'm happy to have that discussion with you to see if we can come up with a model that works for all the parties. We actually have 26 full-time PhD or equivalent scholarships available. So it will be a first in, best dressed situation once that we've expended our funding. The opportunities will not be available, and we would like to actually get them started no later than sort of June 2024, particularly for PhD students. So in terms of eligibility, the ideal candidates that we're looking for would hold Australian citizenship or permanent residency, or perhaps be, may not be a citizen now, but could be eligible for citizenship at the end of your research studies. We would like people to consider if they're in your final semester of study. You may not have all your final degrees yet, so we'd be willing to look at conditional offers for people commencing next year. So certainly don't let that put you off that you haven't finished your studies. But if you're in your final semester of study, please do consider this as an opportunity for you. Once again, if you're currently working in defence industry or ideally with one of our partners, you'll be a perfect candidate to be able to consider a scholarship opportunity if you're interested in building Australian sovereign defence capabilities. This may be one of our projects, may be something that really wets your whistle and something that you want to sink your teeth into. So in terms of your academic abilities, we'll be looking to offer scholarships to people with fairly high GPAs of 5.8 and above, or perhaps you've got equivalent relevant industry experience to undertake a project that you could use as part of your entry criteria that we'll be happy to consider as well. So people may have had a undergraduate degree from 10 years ago. Please don't let that put you off. That's something that we would work through with you. If you would need to have if you didn't have an honours degree, you would need to have a significance for a research project in order to enter into a PhD or professional doctorate. So please do keep that in mind. And there is a minimum admission requirement separate to the scholarship eligibility requirement. So at UNSW, that is around a HTB honours or University of Adelaide around H2A. We would consider you to be eligible for consideration. So in terms of our projects on offer, we have available opportunities from SRC Oz that you've heard about from Brian. Northrop Grumman has a current opportunity. Silentium, DRAC, that you speak to Chris Escott about. CAE for Alexandra, SAB for Dennis, and also a Canberra SME, Geo Jones Australia. There are more opportunities coming, so I do encourage you to refer back to this link on the screen. As I mentioned before, the slide pack will be available to you, so you'll be able to access the QR codes, etc. Actual application is a two-step process. So once you find that project opportunity that interests you and a supervisor to work with, please do keep checking back at that website, having those conversations, finding the potential opportunities. Once you have your project and your supervisor, there's an expression of interest form that's available, and we ask you to email the form together with your CV and your transcript to the primary supervisor. The supervisor will then assess your academic ability, and if you're deemed suitable, they'll then advise you to formally apply for admission through the respective graduate research school. I feel like that's a lot to take in at the moment. If you have any questions, feel welcome to come back to me, but your primary supervisor will actually step you through that process as well, but happy to take questions. So what's next? Keep having those conversations. Conditional offers, like I said, if you're in your final semester and don't have your final grades, still continue to go through the process. We will consider conditional offers. Think about what area of interest really interests you, but also where the opportunities are for sort of cross-disciplinary research as well. Because a lot of the skills that you pick up in any sort of engineering degree are quite transferable to many of the projects that we have. Follow up with your PGCs. Speak to some of the current HDR students in your school. They'll be able to talk you through, like Michelle has, some of the pitfalls, some of the positives, and really get a feel for what you're getting yourself into. Great to have those discussions. As I mentioned, we are looking at starting all of our candidates before June 2024. So applications will close once all the scholarships are filled. So if you're interested, please do crack on and start having those conversations. I've also provided a link there. If you do want to find out more around defence research and defence capability at UNSW and the University of Adelaide, please go back to the slides and do so. So that's brought us almost to the end. We will have a short Q&A session, but I wanted to leave you with this final slide from me. We started with thinking big, and I hope now that you've been through the presentation and heard from some really interesting and exciting speakers, that you will think differently. Think differently about what you want to do for the future. Think differently about who you want to engage with, what your pathway looks like, what your potential career path looks like, who you want to be engaging with, who you want to be networking with, what you want to do in general. And please do reach out, ask questions, have those conversations, speak to others about it. I encourage, I see we have a few questions in the chat here. Look. Okay, so Alexandra, you're still online? A couple of questions for you here. Alexandra, are you there? Let me have a look. So 2 general questions from Vin. Hi, Vin. How are you? I'm glad you could make it. What do you know now that you wish you knew at the start of your PhD journey? Is there somebody still online that would be able to answer that? Maybe Chris?
Yeah, okay. So the question was, what did I wish I knew when I started
Yeah.
my PhD that I know now? So I'm going to repeat something that I said during my presentation, which was that it doesn't lock you into a specific role or specific career trajectory by doing a PhD. When I started doing my PhD study program, that was a real unknown for me, exactly where I was going to end up, because there wasn't as much money around, there wasn't as much industry as there is now. And so, you know, I thought that I was locking myself into what was going to be quite a narrow, very specialized career path. But that's definitely not true. The skills that I picked up were very much translatable. But that wasn't something that was immediately obvious to me at the beginning. So I hope...
Thanks, Chris. And just a follow-up question. What do you consider are the most important factors in choosing a PhD supervisor? And how did you go about it?
Yeah, so I think you really need to work in the same way as your supervisor. So you need to understand how you work efficiently, you know, how independent you like to be, how much support you need from your supervisor, the way that you communicate, you know, whether you need to be sitting next to that person and really be hands-on with them to be able to learn, or whether you're more independent and you can do things at a bit more of a distance. So you need to make sure that when you're just talking with your supervisor, you really understand how they work, how their team works, and make sure that you are able to fit into that kind of culture of work. That's what I would say is one of the most important criteria for choosing a supervisor.
I would agree. Alexandra, thanks, Chris, did you want to elaborate on that? And then we'll go into your question.
Yeah, definitely. I just would like to add, so the first and foremost is to set up expectations. and establish that open communication between, you know, your supervisor or potential supervisor and yourself. So to be able to communicate and discuss ideas and never assume. So that's where some issues may start building up because of some misunderstanding, or I thought and I expected that. So really just probably even entering to have that preliminary discussion, you know, with a potential supervisor. So what is it like? What is it, what are the expectations? What's their potential, you know, part from each party, you know, like expectations from both parts, and yeah, just really like set those goals, and everything is possible.
Right. So Alexandra, a couple of questions here for you around the CAE project. Are you planning the project to be exclusively AI focused? And if yes, do you already have a preference for a particular method, e.g. modeling, ensembling, etc.?
That's a great question. In brief, so the project will combine not just AI-based, you know, technical knowledge necessarily, only one part. So obviously we're working with a simulation with the biometric data, and we are working to see how that data that we can obtain potentially maybe transfer or use to develop some algorithm, or use already established algorithm from CAE that they have, and trying to test that. For example, we can test whether AI-based feedback could be provided after the task or during the task, and we can test that component. So I think that's also that collaborative process that we need to talk to. So I don't think at this stage we're really looking for someone who will be purely having only those computing skills and focusing on developing artificial intelligence technology. I think still the focus is on that human factors part and the training, and just to combine those skills. So it's not just purely AI in terms of a technical side only, so if that makes sense. Also, in terms of that, so a candidate has an opportunity to work, or part of the internship as part of this PhD opportunity, with the industry. So that actually can be in that environment and have the access to their documents and the training and people to talk to, and obtain information about the AI component. So sometimes it will be related to that. So I'm happy to talk further to those who are interested, and yeah, just like see what the expectations could be.
Yeah, I think that, and I think that's a really good, your answer there is a really good segue into the follow-up question that Andrew has, was around, are you open to a combination of various modes of logic? For example, utilizing semantic reasoning, ML inference, and fuzzy logic in an integrated system. So I think you've sort of implied that would be the case, because you'd want to sort of collaborate around the approach.
The only part I would add is I would say that it is important to understand what the industry has developed and what they have in mind as well, so that we don't start from the beginning, but we utilize all available resources, and there may be some preferred systems or technology that they use. However, of course, as a PhD, it is open for new ideas and exploration along the way.
So there's a question also around this, what level will there be access to the CAE UAV flight and sensor simulator? The black box API, etc. Would it be able to be used for live testing of hypotheses?
Yeah, definitely. So the simulation is available straight away. So simulation will be based, for example, at UNSW Canberra, and that's the part that there will be specific personnel who will train the candidate how to use, what to do, how to obtain data, what does a data collection look like, and obviously together with myself we'll look at different biometric data, so all the technologies available. And I think so the component, obviously, as you've seen, of any PhD will start from the literature review. So, and the literature review will direct us to a specific component based on theory, based on scientific evidence, to where the focus of AI developed by CE is at the moment, so, and which aspects we can train. So obviously you may see when you request probably the extended version of the proposal, so there may be some specific research questions and more information about it. Again, I'm happy to talk through with those candidates who are interested.
Great, thank you. Andrew, some really good questions there. I do encourage you to follow up with Alexandra directly and sort of have those discussions. Also happy for you to loop back to me and I can put you in touch. I did have another question here that I'll answer now because we're almost at time. It's around, are there any masters or PhD topics available in guided weapons or hypersonic space or similar? Not at the moment, although I do have some that are currently in discussion with a few of our defence industry partners. It was an anonymous person that posed that question, but if you'd like to contact me directly, I'm happy to talk you through that and put you in contact with the people who are having, the academics who are having the discussions. So please do loop back to me. I will once again, we've come to an end. We're bang on time, I believe. Thank you so much, everyone, for your time today and for showing interest, and also for our speakers for supporting Defence Trailblazer. Dennis, you've just popped up there again. Hi. We will certainly be in touch. Please do look back to me. You have my contact details. I'm happy for you to contact me directly to have a further discussion. And please do stay in touch if you're interested. Keep your eye on the links. Thank you again. Have a lovely rest of the day. I hope the sun is still shining where you are.